Hi, my name is Juan Lopez. I'm a senior student at San Francisco State University. This video is for our final project for our Engineering 415 Mechatronics class. And yeah, thanks for watching. Just to start with the quick introduction of the project, the picture on the left is the one that I created and worked on, and then the picture on the right is what it's supposed to look at. And then, it's the Arduino Engineering Kit drawing robot. Here in the picture now, we see the actual kit, the Arduino Engineering Kit version 1. And then on the left, it's a rover robot. That's one of the things that can be built using this kit. Another thing that can be built is a self-balancing bike. And then we also built the drawing robot. And then highlighted at the bottom is the brains of it all, the MKR 1000. Here's a close-up of the MKR 1000 that we used, and on the left is a list of the main components that we used. Of course, we used the Arduino MKR 1000, the MKR motor shield, 2 geared DC motors with rotary encoders, 1 servo motor, and a LiPo battery. And LiPo is a lithium polymer battery. The way it works is that on the picture on the left, there's the 2 geared DC motors. And then way above in the image, there's almost hinges that it's hanging off from like a fishing string, like wire. And then it's spooled within the spool. And then as the DC motor reels it in, it can go up, down, left, right. So it can move in an XY plane, a 2-dimensional plane. And then the way it draws is on the picture on the right. There's the servo motor, and it causes the markers to go up or down. You can use 2 or you can use 1, and then if you're using 1, you can just make the marker go up or down. And then the way it works with the servo motor, a gear is attached to the servo motor, and then the pen is attached to like a rack. So as the gear turns, the marker will go up and down. When you buy the kit, you get access to Arduino's booklet, essentially, online. And on there, you can find each one of the kits that you should be working on, including the drawing robot that we did. And then it basically walks you through each step on how to build it and how to make it work. There are several chapters, but here's one little snip of how it's basically explaining to us how to set it up properly and take the measurements to put it in the code so that it'll work properly. And here's some of the code that is given access to us, and it basically walks us through each little step from the very beginning of just connecting the Arduino to inputting the measurements that we took, calibrating it, and then at the very end doing the image processing. So what we would do is put in a picture, and it would process it, and it would plot it out so that it can be drawn on a 2D plane. Now what we can see here is some of the code at the very end where we can input any image and it'll process it for us. In this case, we chose the MathWorks logo that you can see on the right. And then down on the code, you can see it taking lines from the image and processing it. And then later on, we'll be able to see an image where it's fully processed on a 2D plane that we can draw. This is what a fully processed and pixelized 2D rendering of the image would look like. This makes it very easy for a robot to draw. It knows the scale, so it'll be really small and easy to draw. So after you run the code, it'll ask you to input a new length for the left and the right string, and you just measure that and input it, and it'll start running. Here we can see that the robot is moving and drawing. And yeah, it takes a long time for mine just because that's how it is. I did all of you a big favor and skipped a huge chunk of the middle part where it's actually drawing. And now we're towards the end where it's finishing the drawing. And yeah, you can see that the MathWorks logo is visible and it went onto the background a little bit. And here's a picture of the finished product, a MathWorks logo. Now we're getting to the final part of the project where we hold up a picture of whatever we want and the software processes it for us. After you hit run, you are then asked to update the length 1 and length 2 of the string, where another window pops up. This time, you are to hold up a picture to the webcam and let it take a picture. The software will then take in that picture and then pixelate it, where it will then plot it on a 2D plane for the robot to draw. After it's done processing, the robot will begin to draw the image. And again, I cut out a whole bunch so you don't have to sit there and watch it. Looking back at the process image, I see where I made a huge mistake. Being that I don't have any more plain white paper, I was forced to use the engineering paper that I have, but with taking the picture with it, everything was processed along with it, along stuff from the left and the right of the actual piece of paper, and also the grid lines on the actual piece of paper were all included in the picture. When I ran this code with the picture that I took, it took a really long time. It started off really messy, and it was a whole complete mess. And now what we see is a finished drawing of the rendering that was previously shown. So what happened there was it was scaled to a very small square, and it did attempt to draw every single little thing that was shown on the left side of the paper and the right side of the paper, and the little grid lines that were also taken from the rendering. Although it looks ugly and messed up, the code worked and it did what it was told to do. At the end of it all, I faced really big issues when it came to this project. First of all, the MKR 1000 board had a lot of issues where it did not want to connect to the computer. It would show on the command window that MKR 1000 is detected, but when I tried to run something to the Arduino, it would say that the hardware is not properly plugged in. After countless hours of trying many different things on trying to get the board to work, I ended up borrowing one from my professor. From there, I had a functional board and was able to upload code to the board and have the motors working. What was happening was my left motor was working correctly and it was doing what it was told to do, whereas the right motor was just spooling uncontrollably and getting the wire tangled every single time. As you can see now, looking back at the image of the board and the DC motor with the encoder, the little piece in the middle that's cracked open, that is the actual encoder sensor itself. That was broken. I never took that out of the box. I found that in there after I had noticed that the left motor did have it and this right motor did not have it. So this whole time where I'm spending countless hours trying to figure my code out, recalibrate things, it was just a broken motor. I guess it's my fault for not really considering that a piece can be broken. But my thinking was, having worked in robotics in the past and never really spending much money on it, this kit was $300, and I guess I just expected that the pieces would be working. Don't get me wrong. In theory, this was supposed to be a very good kit. There was just a lot of little things that were wrong that made it very hard to work with. Thank you so much for watching. Bye-bye.